I do want to say a big thanks to one of our sponsors for allowing these sessions to happen. Rheem. Rheem has the Rheem Prestige. This is a hybrid all-electric heat pump water heater that has up to near 350% energy efficiency by taking the temperature out of the air, even today, and heating it with electricity to heat water without any kind of combustion, off-gassing, or anything like that. And so this is a great system for doing that, and can be non-ducted in many situations, or also now ducted in other situations that may require ducting systems. And then thanks to our main sponsor, T-Stud. T-Stud has structurally insulated framing systems. So these are all the wall stud assemblies, foamed right in place, delivered right to the job site. And it has an internal truss system, and it's just one product that helps alleviate construction concerns such as thermal breaks, structural strength, wind loads, sound transmission, and fire and life safety. These particular products can be utilized again for a majority of the wall assembly, and then they're also being designed for the roofing assembly. And again, they can be utilized to replace for the most part exterior insulation at a much cheaper cost, and same ease of build as your normal 2x6 24-inch on center wall stud assembly. Now, what I really like about T-Stud is they're coming out with a 2x8 system, and so that's going to increase the R value of the wall by R30 to R40 depending on what kind of insulation you use. And then they're also going to be shipping without insulation in them. So if you're doing a renovation project or you just prefer to insulate it yourself, your insulator can do that right in the field. And you could choose a different insulation other than foam if that was important. So that'll be coming out hopefully next year, but these are shipping across the country now. Go to tstud.com to learn more. All right, well, welcome everybody to 10 pro tips to getting a home, multifamily building, small commercial buildings to zero energy with ease, without too much thought. It's easy to do now. This course is approved for 1 hour in continuing education units, GBCI, AIBD, Certified Green Professional, Certified GreenHome Professional, BPI, NonWholeHouse, CEUS. It's also approved for health, welfare, and safety from the American Institute of Architects, which may make it applicable to your state-based design or contractor license. Today, I am your presenter, and my name is Brett Little. I'm the executive director here at the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. And so what we're going to be talking about today are affordable ways to get to zero energy, and really discussing is if it's really that much of a barrier or hard to do anymore with current technologies and the direction that we're heading. So zero energy is expanding all over the place. The New Buildings Institute has been tracking this year over year, and so you can go to their website and learn a little bit more about that. They're tracking all sorts of projects and breaking them down by building type. But one thing is clear, that the zero energy movement is taking off, and it's moving quite rapidly. But what does zero energy mean? When we say that, what is it that we're actually talking about? And so we've got net zero energy, zero net energy, net positive energy, zero energy buildings, zero energy ready, zero energy capable, no utility, off-grid, zero carbon, zero emissions, and that only is maybe half of all the things that one could say in this context. So what I was getting at is we're really in a Wild West situation here, where it's early enough in the zero energy movement where anybody can use these terms without any kind of repercussions or recourse or pushback. It's kind of just a term that can get thrown out and not have too much meaning at this point in time. And so before we get to what we think zero energy means, I want to make sure we cover some brief things on what it's not. And that is, the first one is, it's not offsetting your electric bill only unless you have a full electric bill and no gas. But especially where we're at, cold weather climate states, 70% of the energy is used in gas or propane or wood heating. So we're not talking about ignoring that. It's also not having necessarily a $0 utility bill, though that is in the direction we want to be in. It's not necessarily that, because there's a lot of reasons you wouldn't have a $0 utility bill, or you might have a negative utility bill in these cases. We're not talking about going off grid, and in fact, we're encouraging everybody to stay on the grid and to work with the grid and participate with the grid. It's something you definitely want to do. And then in this case, we're not talking about having battery backup whatsoever. That's not a part of the conversation, though it's, again, not something that shouldn't be a part of the conversation. And we're not necessarily talking about a HERS index rating of 0, though that is heading in the right direction. And we're not talking about a LEED Platinum certified building or home, but again, in many ways, that's heading in the right direction. And as far as natural gas or combustion goes, that's debatable, but we'll talk about that here in a second. So when we say zero energy, and I think this is the definition that the industry is heading to, is a home that produces as much renewable energy as it consumes in regular energy over the course of a year long. And so what we're going to be talking about today is how do we do this? And so we have 10 tested tips, pro tips that we're looking at that we've sort of accumulated across the years working with the project teams that we've worked with and seen and interviewed, and kind of put all these tips together just based on what we've actually seen happen out there in the real world to help you sort of break down that barrier to be able to do this. And just so you know, this is an ongoing conversation, and we update this conversation every 6 months or every year because things change, technology changes, new ideas change. And so we're not ending the conversation here by any means, but we're going to keep having this conversation with you all and others to refine this, into the future quite frequently until we can get everybody there. So what we're looking at this is sort of in a pyramid fashion. And at the bottom of the pyramid are the first tips that I'm going to get to, and then work our way up. And at the bottom, we're talking about things that are really, really hard to do later. If you don't do them right away at the beginning of a project, or the longer you wait, the harder and more expensive it gets to do it. It could end up being cheaper and saving more energy in the upfront. And then as you move up that scale, it becomes easier to change these things later on in the project, but they can be more costly and probably save even less energy on a per dollar basis. So that's kind of the way to look at this zero energy pyramid. So the very first tip that we recommend to everybody, that is the cheapest thing to do, that effectively might have zero cost to it, is making that commitment. And so that's getting the entire team together, the entire build team, the design team, no matter who they are. It could be one person, it could be 20 people, depends on how big the project is, how many hats someone is wearing. But that's getting the folks on the team, the builder, the contractor, the subs, electrician, HVAC, architect, even the landscape architect is going to play a role in doing this and helping you out. The plumber, the owner, the funders, the financiers, the developer, you name it. We need everybody kind of at the table saying, you know what, we can do this. We're committed to making this happen. It may seem difficult. It may be trailblazing in our area, but I think we can accomplish this kind of goal. And at the end of the day, there are going to be the naysayers on the team who say it's impossible. And I'm not necessarily saying that you don't want to hire those folks or work with them. You may even be that person, and that's okay. I do actually find that a lot of the folks on the team who are naysayers in a more constructive criticism kind of way, where they actually have valid concerns and bring those concerns to the table to help you, think through your ideas and not move forward with something that doesn't make sense, is actually very helpful, even if they're, completely at the start saying, hey, we can't do this, it's going to cost too much, it's impossible. There could be some value to those folks being on the team. So that is one thing to consider, and know that, commitment is good, and maybe there won't be 100% commitment, at least from the start. Part of the commitment is maybe getting educated, and so that's what we're here to help out with. We actually have a thing on our YouTube channel where we're bundling all our zero energy programs together under one roof. And so everybody can log in and see that on our website and watch that at any time. Home tours, other types of education, this session, you name it, that'll all be up there. And so it is important for people on the team to go get educated in their relevant way of education to learn how to do something like this. And then during that process, you're going to have a lot of iterations, right? Probably, especially when you first start out doing this, it's going to be a very iterative process where everybody needs to be communicating and understanding their role in this process, and knowing that, you know, plans are going to change, specs are going to change, things are going to go back and forth, maybe a little bit more than normal, and be willing to kind of have that dialogue and update everything as you go until you're finally ready to start moving forward on the project. All right, so you've made that commitment, you got the team on board, everybody's aware of the goals of the project that you want to get to zero energy. And so the next step is to really have a good understanding of what you're working with on the site. Or if you're fortunate enough to choose your site from the beginning, then you might look at the way you're choosing the site that you're building on differently through the lens of zero energy. And so the very first thing is you can use a free tool called the PV Watts calculator, and you can punch in the address of the site or a list of 10 different sites that your client may want to build in. And then from that, you can kind of measure out the site, and you can use some of their education tools on here that teach you how to sort of design a solar system. And what I like about this is that it basically tells you what your maximum output of kilowatt per years on the site is going to be, depending on where you want to place that solar system. And so really from there, I like this idea that you're kind of working backwards. And so you know, if it's an existing home, you're really limited on maybe the space on the roof and what direction it's facing. So that could constrain you even more. But you know that your energy efficiency goals then need to meet this number right here, and you need to be able to hit those energy savings to be able to come zero energy. So it really sets that expectation from the beginning. From there, you might go out and hire a solar professional to take a more in-depth review of the site using tools like solar pathfinders. I think there might be drones that can do this now. There might be other satellite technologies, but the whole idea is that you're going out and doing a more in-depth review of that site to figure out where best to place the home or the solar panels to take the most advantage of the sun. And so here's a project from our Value Homes up here in West Michigan that, you know, utilized solar resources to figure out the best placement of the house on the site for future solar in this all-electric zero-ready home. The other thing about taking advantage of the renewable resources of the site is geothermal. So geothermal isn't necessary for a zero energy project, but it might make sense. It certainly is something that a lot of people use. And so you might need to determine with a geo expert on what's the best way to run your loop system in the most affordable manner. Or are you doing a neighborhood or a community? And so if you're doing a community of homes or multifamily buildings, you might want to do some kind of utility scale geothermal grid. And so again, you're just trying to figure out where best to place those geo resources. Is it going to require you to kill trees? Do you want to do that? That's just sizing up the site, again, for the geothermal resources. Now, this is pretty small, but there are opportunities in certain sites for small scale wind. It barely ever has a return on investment. And in some cases, there are technologies coming online for small hydro systems. And so, you know, micro hydro as it's called. And so there might be an opportunity to put a micro hydro up on the site as well and, you know, get some kilowatts out of that. But, you know, again, that's usually very rare and much more site dependent than solar, which, as you know, for the most part, the sun is shining everywhere. And so we've got some sessions on our website here you can check out using the PV Watts tool for easy solar assessments. And then we have a session on geothermal where they talk about site assessing for proper geothermal resources and ground source heat pump resources. So you got your commitment, you now know what you're working with on the site. And so the next step is to kind of continue that conversation with taking advantage of the sun. Now, most projects just try to, in the past, kind of, homes get overheated now. Now homes, especially in our climate, they're really just designed to shield the sun out and keep it away in the summertime, but really aren't taking advantage of it to access its warmth in the winter or free light during all hours of the day, which is unfortunate. So we know, like, this LEED Platinum zero energy ready home up in Stanwood, Michigan here is taking full advantage of the site with some overhangs here that keep the sun out during the wintertime, with a white roof here that's reflective of the sun, so it's not overheating the house. And then in the home, there's concrete floors that during the summertime or the wintertime, when the sun is low, it comes in and heats those floors up, and it sort of radiates out throughout the day. And then you can see some light windows up here that are going to be letting that natural light in at all times. And so again, here you can just see examples of overhangs, which are a really good idea and easy to implement during new construction. Overhangs also have a secondary benefit. They're worth some LEED points, and the reason, or other green building rating systems, and the reason for that is they keep out moisture and water from getting into our fenestrations and rotting them faster, and they keep the light from reducing the look on them or fading them, and so they help preserve material. So they do have that secondary benefit going beyond just keeping the hot summer out. And then again, and this is a Living Building Challenge certified, the second home in the country over in Ann Arbor, Michigan, by our member Architectural Resource, and they've got a trom wall system behind here, which is basically a system that's capturing the heat of the sun during the wintertime and using it to radiate out through the house. This is a pretty cool LEED Platinum near zero energy home in West Michigan. You can see they've got these light shelves here, and you can see the light shelves from the south end. The light comes in the window, penetrates into the kitchen, penetrates further into the bathroom here, and this bathroom over here. And so you can just see that light just comes right in and lights up the whole house, and reduces the time for artificial lighting. And then we've got, this is a Facebook post from one of our friends at R Value Homes. During the polar vortex that we're experiencing now, just going to show that light that's coming in with proper passive solar design is hitting the floor and heating up the entire house and using effectively free energy, even when it's sub-zero temps with, negative 30-degree wind chills out. The light, as long as the sun is still shining, it can come right in and heat everything up. And so we have a session on our website. You can check out passive solar design and online tools for window shading and analysis. And this is in the context of LEED, but can be utilized even for non-LEED projects. And then also, getting into other types of projects, multifamilies tend to overheat and have high cooling loads. So it's always a good idea to just try to keep the sun out of those, even sometimes in the wintertime. So that can be done through overhangs and or good solar heat gain coefficient numbers on the windows. And then renovations obviously are very specific to the house itself. It can be very expensive to try to change walls or add in overhangs, depending on what the budget is. And so it'll be very subjective. You could retrofit in something like a dynamic glass, which can basically let the sun and the heat in when needed, but keep it out when not. That could be one solution for renovations with this kind of aspect.
This conference will now be recorded.
So you've made the commitment, what you're working with as far as renewable resources on the land, and you've made a design that's hopefully taking advantage of the sun, not just trying to keep it out. And so the next step is to do what we call right size spaces. And so right size spaces are basically ways to take more advantage of conditioned space and spaces in housing, and And so you're taking advantage of these spaces, and one of the things you want to make sure to do is not oversize a house. And so on one extreme end, we have growing sizes of home that not only take up materials, but you have to pay to heat and cool that extra space in these larger homes. It's just a reality. And so having what we call more useful space, you're not going to be paying, your clients are going to be paying to heat and cool space they don't need. Now, the answer to this has typically been the tiny home movement, which sounds really cool, and I like the idea of it, but the reality is we can't expect everybody to live in a 200 square foot home. And so we just don't see that happening anytime soon. So what we want to do is make sure we have right-sized spaces that only need to be heated and cooled when available. And so real quick, can anybody just take a guess here on, so take a quick guess here on what, which home, just with all things being equal, you can tell they're super efficient homes. But with all things being equal besides that, which one of these is going to use more energy? And this is, utilize more energy with all things being equal. Right, yeah. So what we're talking about is surface ratios here. And so surface to volume ratios. And so again, with all things being equal, a house that's built its square footage lengthwise, maybe a single story versus stacked two-story, is going to inherently, no matter what, just use more energy. So that's one way to consider maximizing space and thinking through the usage of space for reducing heating and cooling loads. If you've ever followed Sarah Susanka, she kind of has rebranded to the Not So Big Life, but she still has a lot of ideas and still shares a lot of very helpful tips for your clients in the design stage or renovation stage on the Not So Big house. And again, just taking more effective use of space. And so anytime we can make a better use of space, we are ideally reducing conditioned volume space and then reducing our energy demand to help us get to zero energy, maybe effectively for no cost. We've also got here, right in Grand Rapids, Michigan, a startup called Urbaneer. And Urbaneer is pioneering designs and products to help, again, reduce space. So this is a 800 square foot home, which is it's basically the most illegally allowable size home in Grand Rapids, Michigan, where I'm from. I know not everybody has zoning codes like that. But the idea is that this house is designed to feel much larger on the inside and function much larger using these strategies in an 800 square foot home. And so, things like wall beds, movable walls, adjustable islands, and all sorts of other technologies, again, can make a space more useful and not have to have you design it so large to take advantage of that. And again, reduce those heating and cooling loads on the house. So you've made the commitment, you know what you're working with as far as the solar income or renewable resources. Your design has taken as much advantage of the sun as you can for free heating and cooling, and even ventilation in that matter. And then you've designed a space or redesigned a space or renovated a space to reduce the amount of conditioned space need without harming the size of the house or the feel of the house or the utility of the house to the occupants. And then the next step is to aim for passive house. So I saw a question in there, what about passive house? And so our response to passive house, be it the German version, the international version, the US version, whatever, I say those interchangeably, and I do understand there are differences, but the whole idea remains the same. And our thought to this is that you should definitely take the passive house program and you should download it now, German or US, and you should hold it up as a standard and as a model and say, okay, this is what we're going to aim for. This is what we're going to achieve to help us get to zero energy. And then you should recognize that as you're going through the design process and even the build process, that you're most likely not going to achieve it. And don't beat yourself up for it. Just realize that by inherently aiming for passive house or doing what we call the almost passive house, you are going anywhere from 70 to 90% better than code and you're doing really well, and maybe you're just going to get dinged in one area or another, and that's okay, because this is going to be the design standard to really help you get to zero. And if you do it right from the beginning, it's going to be the most affordable way to get there. That's also going to add some resiliency to the home. For those of you who are, we're going to be doing a passive house session coming up on the new 2018 standard. But just real briefly, what we're talking about here is just fully thick insulation enclosed all the way around every part of the house from top to bottom, for the most part, no matter what climate zone you're in. And then we're going to be talking about insulated walls. For sure, we're going to be talking about insulated walls, potentially up to, in many zones, especially the colder weather climate zones, R40 is what we want to see. And then we're talking about really thick insulation and air sealing done in the attic, maybe up to R80. Again, that just depends on where you're at. And then we're talking about ideally slab on grade construction, but even if it's a basement construction, which doesn't typically by code require insulation, we still want to see that insulation under the slab and around the entire basement. And then we're talking about really good, really low U value windows, maybe 0.21, 0.2. Double is fine. You don't have to get into the triple pane really, because at some point there is a diminishing return. But you can go triple pane depending on what your goals are. But we see lots of double pane windows, American made, fantastic windows down to that 0.2, 0.21 zone that really help achieve these types of zero energy projects. And then you're going to be talking about a super tight building shell. That's usually measured at air changes per hour, though the measurements now are changing more to CFM at 50 per square foot of enclosure. Still trying to wrap my brain around what that means exactly, but most passive house projects have been looking at around 0.6 air changes per hour. I just heard of one that got down to like 0.1 recently in the Northeast. But again, you want to keep that air from leaking out, and you want to keep comfort in, and so that's something you want to get done during the design or renovation or build stage, and have a good air sealing package put together to achieve that. The next thing is conventional framing, and so what you want to try to do is avoid standard 2x16 or 16 inch on center framing. Ideally want to use more of a 24 inch on center framing, because then you're reducing the amount of wood members that go from the interior space to the exterior, which just suck out heat. And by the way, you're also paying more for wood and then using more wood resources to build the house, which can produce more waste. So there's a lot of inherent benefits by switching over to a 24 inch on center advanced framing strategy. And some new technology that's coming down the line to, again, help reduce costs, because that's what this is all about, are called structurally insulated framing systems, or SIFs. And so these are pre-insulated wall stud assemblies that can help reduce that thermal bridging without the expense or the headache of exterior insulation, which I know many builders still don't like to deal with. So this might be one more affordable strategy to use without having to do that exterior insulation on there. So you've made your commitment, you have your renewable resources figured out on the site, you've taken advantage of the sun to heat, cool, ventilate the home, passive cool. You've downsized the space to being a right size, so you're not heating and cooling unused space that your clients don't need. And then you've put together what we call the almost passive house thermal envelope approach. So you've got a super tight building shell. So I'm going to tell you, just stopping right there, you are pretty much anywhere from, depending on if it's a renovation or a multifamily building, or a new home, you're anywhere from 50 to 90% of the way to net zero by just doing these things. And the first 4 of them, you could almost argue, could be free. And they just really take a different way of thinking or approaching design. Making a commitment has no cost. Potentially assessing the site, a lot of the professionals you'll be working with usually just do that because it's the right thing to do. Number 3 might take some more of your time, to think through that passive house design or that passive solar design approach. But once you get it down, you can just implement it, copy paste. And then right sizing a space, if anything, will reduce the construction costs if you have a smaller space. So you've already potentially saved the client's money there on having to pay for a larger space. And then, of course, most of your money is going to get thrown into number 5 there to beef the wall and thermal envelope up. But again, that's going to knock out most of the energy needed ever throughout the life cycle of the house. All right, so moving on past that, the next step is arguably to hashtag electrify everything. And let me set this up for you here. I mean, if anybody's heard about what recently went on back in August, I think it was, early September over in Boston, just massive explosions due to the wrong type of gas sent down the gas line from the natural gas company, doing significant damage and unfortunately taking some life away. And then even up through Thanksgiving and into the holiday seasons, people still did not have access to hot water or natural gas, or couldn't safely live in their homes. On top of that, we saw that nearly 1 million gas-fired water heaters were recalled due to a fire risk. And we know that combustion appliances, 1/3 of the reasons fires even start in a home are due to combustion appliances. I think the other third of the reason is now due to fireplaces being in the home, which again is combustion. So what we have with combustion is carbon monoxide. So you've got to keep your clients alive. So you've got to get that carbon monoxide out of the house. So what happens when you're trying to get that combustion out of the house? You've got leaking chimneys. And when I say leaking, I mean air loss. But I also mean when weather like this here in our polar vortex, you're going to find a lot of the flashing around chimneys is going to fail, unfortunately. And so there's going to be leaks in homes now through those chimneys. And some of those chimneys are just, nice looking. People have high efficiency furnaces that don't even use those anymore. But that's another problem of trying to get that combustion air out. And then, of course, through all that venting, you've got heat loss, and then you've got potential pest entry that can come in through the penetrations through the home. The other issue that we have here is if you've ever seen a heat load calculation, which is a really good idea to do for a home, especially if you're doing a green certified home, helps you understand how big the heating and cooling system needs to be. Most of the homes that are going for zero now have so small heating and cooling requirements, especially on the heating sides, that they don't even make gas equipment anymore that gets down to that, or if they do, it's very expensive, and if a part breaks, they don't have anything available to get access to that part. So is there any innovation in gas? So, gas kind of tapped out at 98% efficient. It can't get any more efficient than that. If they were able to lower the cost of the heat load demand, so smaller units, and make them more affordable, that might be called innovation. But the funny thing is about, the next level of innovation in gas systems is actually the dual fuel hybrid electric systems that work down to a certain temperature and then the gas kicks in. So it's electricity that is the next level of innovation for natural gas and propane furnaces. The other concern that we have is that renewables at the end of the day can't offset combustion. And so you can buy 20, 30, 50 solar panels, 1,000 wind turbines, but if you're burning gas at some point, at no point in time does that renewable energy suck back in the emissions that were made from combustion. So it just really can't be offset on a one-for-one basis. So they tried this back in the past. This is our former president, Ronald Reagan, when he was working with GE before he was president. And the whole idea was that we could live much better lives going all electric. And I think the idea, unfortunately, was ahead of its time, but now the time has arguably come and we're there. We're already seeing this happen with electric cars taking over the market, dominating the market, outselling everything else out there. We've just seen that Ford and other companies are launching all electric trucks that in some instances work and perform better than their gas counterparts. And then for better or for worse, our cigarettes are even going all electric and don't even have combustion in them anymore. So that is the direction that we're going. This is the Energy Information Act EIA data here. And so this is, you can just see the growth of the yellow there from 1993 to 2015 in each of the entire country is on the left, and then Northeast, Midwest, West, and South heading out to the right. And you can just see the bar charts for share of electric in yellow compared to electric in another fuel, or electric in two other fuels, is just growing off the charts. And you can see in places like California, no surprise, massive neighborhoods that are all electric are already going up. And so I pulled this report out that was done by Rocky Mountain Institute, and I focused here on the Chicago, West Michigan area. And what I wanted to show you is that in their study, they saw new construction with a standard heat pump. Here was the cost in thousands over 15 years to operate. Here's the cost for a natural gas AC. And then here it is in a retrofit situation, just really pretty much on par with natural gas and AC. And then you can see from the emissions profile, because of the way our grid is set up, you still have higher emissions taking the heat pump. But if you look at this study in any other place in the country besides the Chicagoland area, because they did this for 5 or 6 other places in their study, you will see that all of these numbers are flipped, and that this number is always going to be lower cost emissions everywhere for standard heat pumps. And then as far as the emission side go, once the grid starts to clean up and we have more renewables on it, those numbers will flip inherently too. And so you can check that study out, and we have a whole webinar of it on the economics of electrifying buildings on our website. So what are some strategies? So there are plug-and-play systems, ducted air source heat pump systems. So these are basically air conditioners that work in reverse in the wintertime. And even when it's a polar vortex, believe it or not, there is heat out there. Otherwise, we would not be alive. And so these systems can be plugged right into existing furnaces or built into new furnaces if you still want to have ducting. This is our member, Michael, working on a passive house up here in Michigan. And one strategy that he is utilizing are ductless systems and going ductless. And again, talking about affordability, getting rid of ducts is one of the ways to quickly cut costs, and then also to strategically only place a certain amount of mini splits around a house, so you don't have to have too many of them, which also drive up costs. The other thing about mini splits versus ducted systems is they're significantly more energy efficient, both on the heating and cooling. And yeah, I understand if you don't like that, if your clients don't like that ugly head sticking out of the wall. I don't. It can be hidden up in a ceiling or on a wall, or some kind of fun design you can build up around the mini split so it still works. But that's one way to really cut those costs. As far as heating water goes, again, we've got air source heat pumps that can be ducted or non-ducted. So these are electric systems that are 350% efficient. They have ones now that use carbon dioxide as a refrigerant, which is much more sustainable. And these systems can be used to also heat a house through radiant systems. So they can be used and paired with other ERV systems, or you name it. They can also be serving as the primary heater. And then, of course, again, if you've got a project that demands a large heating load, has extreme cold temperatures perhaps, or just because the house is a little bit larger, or just because you want to go with something that's a little more certain, you can utilize a geothermal system, again, or a ground source heat pump system, take advantage of the heating and cooling of the ground. Your clients can still get that 30% tax credit available for a couple of years. And also they can heat domestic hot water with the system as well. So it can be paired right into it. So that's another one of the benefits. Now there are air source heat pump systems out there coming on the market that are air to water source. So they kind of work like a geosystem. And so if you're running radiant or running a water to fan coil for blowing air, they actually have near the efficiency without the expense of the drilling. So those are out there, and you can message us later if you want some more information on those. But here's one of our LEED Platinum Zero Energy certified projects up in Minneapolis. Very cold place, especially right now. And again, because of the size of their house, it was feasible for them to use geothermal to hit net zero. And if you can see, this is a really tight urban lot back here, and they just bored down vertical holes here in an urban area. So if someone says you can't use geothermal in an urban area, that would be incorrect, though there are certain codes you have to apply by. Now, the biggest problem with going electric is the cooking, believe it or not. The other stuff I just talked about is easy. You know, we got that. People who love to cook love their gas stoves. And so it's very difficult to convince someone. So one of the simplest ways you can do this is you can get an induction, single top plate induction cooktop, purchase a couple of them, or make an agreement with a local hardware store, and then have your clients try them out before they commit to going all electric and getting rid of that gas line. And if they really like the cooktop, then then they can move forward with it. So basically, induction is just heating the pan where it needs to be. It can boil water instantly. You can remove the pan and touch it, and it won't burn your hand. I've tried this before. So it's just not wasting energy. It's 70% more efficient than a gas stove and 40% more efficient than your standard electric stove. And I understand electric is awful to cook on, but induction is better, and it's the direction that even famous chefs are heading in. So you can check out more and keep up with the conversation. We have a whole Facebook public group called Electrify Everything, where there's some of the industry professionals on there sharing tips and tricks in their projects and just having a great conversation about the barriers to electrify everything. So hopefully you would join us there and enter into that conversation. So, again, now that you've hopefully went to more efficient, right-sized HVAC system after completing all the other steps and ideally went electric, now you've got a super tight house with barely any penetrations in it that's healthy and clean because it hasn't any combustion in it. And the reality is you're, probably anywhere from, 70 to 95% of the way there to getting to net zero. And so the next step is really just asking you to get super picky, but to really be smart about that. And so here's Matt Grokoff, happyhome.how. He's somebody who really has educated me on all of this, and he's a real picky dude. But he took his house in a historic home in Ann Arbor, Michigan, and took it down to net zero, despite many of the barriers of a historic home, old existing home. And he's just used a lot of really cool technology with low energy in it to help him do that. And one of the things I like about what his approach is he has thermostats that are monitoring the energy usage, the geothermal. He's got plug load monitors so he can see where his energy is being used and make an informed decision on how to reduce it. Now, if you're doing a small business zero energy project, I think that's where you're really going to want to focus is on your Energy Star computers, Energy Star laptops, cutting lighting load on your machines, making sure things are unplugged when they're not working at the office, and then having a smart plug load management system to help you figure out where energy is being used, again, in a more commercial setting where you might be using other electrical appliances that you wouldn't normally use in a residential home, or even if you have an office in your house. This can help you figure that out. But the reality is, this smart tech and these low efficient appliances, this is where a lot of people start when they think about getting to net zero or an energy efficient home. But like I said, doing all those other things before we got here are going to cut anywhere from 70 to 95% of your load. So the reality is this stuff can only save so much, and we spend so much time talking about all these gadgets, but they really can't save that much energy. I hate to say it, but you're really talking about a small sliver of the pie here and spending a lot of money and debating a lot about it. And so we hope to have you do all the other stuff first and then weed out the rest of your kilowatts here with the devices, and even low flow water systems can help. So if your clients want to get super picky, they can figure out which appliances have been labeled the most efficient. Energy Star does this every year, and you can literally go online and just find the most efficient appliance in each section and buy that one and compare it to the, another brand that, may use 100 kilowatt hours more a year. It's not very much, but again, if you're being picky here. The other thing you can do is, instead of, especially in a retrofit situation, it can be very expensive to put motion sensors and retrofit all the plugs. And so here you might buy a built-in motion sensor LED and put it into hallways and put it into a closet or something. I actually have several of these. They work great. You accidentally leave the light on, you walk out of the room, and then it goes out, and then you walk through, and it comes back on. And they have ones too that can penetrate right through glass bulbs as well. And then the next thing you want to do is go ventless. And so keeping on that idea of getting rid of gas, condensing dryers work great. I had one for 4 years. They'll also allow you to eliminate the hole in the wall. So that's another air source loss that you can get rid of, another place that pests come in. Another thing you don't have to clean, that your client doesn't have to clean, that they're going to forget to clean. And they're more energy efficient. Or you can switch over to a heat pump dryer, which costs a lot of money. But again, no plugs, no vents, and even more energy efficient. So, again, after doing the commitment, knowing what you're working with, taking advantage of the sun, having a right-sized space, near passive house thermal envelope, all electric, right-sized HVAC equipment, and then you've gotten super picky, you've pretty much are there. You've got a super energy efficient home, and there's only really one more thing you need to do. But during the design stage, you're going to have all of this stuff figured out, and you're going to take all of these ideas before you start building, and potentially before you sign all the contracts, and you're going to stop guessing, right? So all of these things here, basically you can do all this, but you're really just guessing that you're at zero, and you're crossing your finger that you made it, but you really don't know. But there's no reason that you can't know anymore. We know, we have the technology and we have the tools to make informed decisions that are pretty accurate. And so the argument I would make here is that you want to do energy modeling early and often. So once you've got the team together, hopefully you've got an energy person on your team who's helping guide you through some of these decisions from the upfront. But even if you pull them in right before you go out to start the project, but still with enough time to make changes, that's okay. What they're going to do is they're going to come in with one of these energy modeling systems. It's all just dependent. Home energy rating works great on new homes up to multifamily 5-story buildings. Home energy score works better on existing homes. ASHRAE 90.1 works better on commercial buildings and massive there's BOPT. The passive house, despite their name, actually work fantastic on all building types. But what's going to happen is this energy professional is going to take all that stuff you planned out in those other sections. They're going to throw them all into this model here, and then it's going to spit out kind of where your performance is. And so you're going to be able to quickly identify, sheesh, the above grade walls, those are just going to be using a lot of energy, and we're not quite at zero energy yet. So what are we going to go after here? Well, this might be the best way to go, is tackling the walls. That seems to be where most of the energy is going. Windows next, slab floors next. And so a good energy efficiency program model is going to tell you this information before you start. You don't want this information after you've started building, because it's pretty much useless at that point. It can't help you. The other thing it's going to do is tell you, where your heating energy is, where your cooling, water heating, lighting appliances, solar can be thrown into it as well. Maybe what your space heating design load is. And so again, it's going to give you that information, so that way you can get the energy down to negative or zero. And so this is a report that gets pulled on REM rate, or the HERS index rating. And so this is the DOE Zero Energy Ready report. One thing we really like about this report is, especially if you're doing all electric, it'll tell you instantly where your electric demand is at when you throw in solar, of course. So you can know at the beginning of the project where your goals are. And then during the construction phase, your energy modelers or your energy inspectors are going to come in. They're going to do the blower door testing. They're going to do insulation testing. They're going to do HVAC commissioning. They're going to look and make sure everything that was in your plan was actually installed. And then if not, they'll warn you, hopefully if they're good raters, they'll warn you to fix it before you close the project out, and get off track from zero energy. But anyway, so again, once the project is done, through the final testing, they're going to re-update that energy model. And again, you want to show that you're hopefully at a negative or zero kilowatt hours per year usage, to be able to show, hey, we hit the zero energy goal. So once you've done that energy modeling though, and solar is not a part of it, what it also will tell you is how much more energy in kilowatts the home needs left, or how much it's going to draw. And so this is a great time, now that you've reduced, to now produce. And so like I said, you're going to use your energy modeling or a renewable energy expert to figure out a minimal amount of renewables that you need to offset the rest of the small energy use that your home needs. And so again, we want you to put your money in the HVAC, and especially the walls and the design, and not put it into solar. We love solar, and we want everyone to go solar or renewables, but they're expensive. And even with the tax credit, they're still very expensive. So we want you to buy the smallest system possible that you need to help offset the rest of the usage. And so even if your client just isn't quite there yet, or they can't find the funding to do it, you can do what we call solar ready. So if you've done all the other things we just talked about, and then you run up lines up to the attic, pre-wire for solar so that it can just be plug and play. You've got a roof facing the right direction, or you've got the ability to put the solar outside or the wind outside on the ground. That's fine. And then the other thing, it kind of got cut off there on the right, but making sure that the breaker box is large enough to handle the solar, so they don't have to go and buy a whole new electric box in the future. You can have a solar ready home. So again, here's that all electric home. And what they did is they went through a full year of electric usage to figure out what their demand would be. That's a smart way to do it too. And you can see the roof is already ready. It's already facing true south. And so the solar can just be plopped right on there, and there's an electric box up there to be plug and play. This is our member Matheson and Matheson home. It's a pending LEED Platinum home that's also zero energy ready, and you can see the solar here pitched on one angle, but we went and filmed this home. You can check it on our website, but you can see from this drone footage that this pitch here doesn't have the solar on it. And so again, they were just trying to figure out how much demand there would be, and then realized after a couple of years they just need to save up for another 5 kW solar to hit the net zero strategy. So again, the whole house can be added with PV on it. This house right here is we call a renewable energy power plant. It's nearly got, I think, almost 20 kW of solar on it. And this is actually enough energy on this house to power all electric cars, leaf blowers, mowers, you name it. It's a fully electric solar powered home. And then solar doesn't always make sense on roofs, or maybe people want to keep it off because of the way it looks. And so they can be like this project. This is a Green Star Platinum certified zero energy home in Fenville, Michigan. And they put their solar right out in the field, sort of next to the house, to take more advantage of the sun without having to cut down any trees. But again, in the spirit of affordability, the question we ask is, why are we putting asphalt shingles on our roof? When water hits them, they put toxic chemicals into the ground. If you want to do drinking water with them for rainwater catchment, it's a filtration nightmare. On top of that, they really can't be recycled at the end of their life, and they typically get landfilled even if recyclability is available. And so now there are many manufacturers coming online, more and more every day, where they just basically have the shingles as the solar panels, and you can typically take advantage of the tax credit both for the shingle and the solar panel. And you can also do this for conventional solar on a metal roof setting as well. And so the question we ask is, why even bother? Why would your clients want an asphalt shingle? I mean, what does it really do? On day one, all it does is start rotting and reduce in value. And so, solar integrated right into the shingles is going to instantly start generating money and help them get to net zero energy. So you've done everything you can. You've taken a focus on design, then focus on the envelope, then do all electric small systems, then get really picky with your appliances. Make sure you've got this figured out through energy modeling, and then put on just a small amount of renewables, ideally solar, or make it ready, and then you're pretty much there. And so really the last tip we can really give you here is to go green and get certified. And by doing a green building certification, at the very least, you get a guidance checklist that not only helps you with energy efficiency, but once you make a super tight home, you want it to be healthy and you want it to be durable for your clients. And that's really where green building certifications stand out, is they give you that pathway and that way to communicate to your clients into the market that you're doing a healthy and durable home for them. As far as zero certifications go, there's several different ones out there, and they all have different features, and we're going to do a whole new session on comparing all those. US GBC just launched a new one as well, which is site-based zero energy, so we'll be adding that and discussing that at a later date. But you know, the green building certifications, again, kind of, even if you don't make it to zero, they still give you something to go off of, something that shows you're committed to sustainability. It still has a good energy efficiency component pathway to it. And again, it's just a way to you know, market that you are committed to sustainability and having a healthier, more energy efficient and durable home. So that's our list there. One question that we ask is, can zero energy homes come in at the cost of code? We have a webinar of one organization down in Tennessee that's testing that out and has been successful to some degree, about a nonprofit that's been partnering with builders around their region to build these types of home and follow these 10 tips, and then sell the homes at a market competitive cost with homes that are around in the area that aren't achieving any of these types of things. And most of their homes also get LEED Platinum certified and are either at near zero or at zero energy. And even from a cost standpoint, if you do many of these things, you're still in the short term maybe going to find that you do come in over the cost of construction code. And so you still have the 30% tax deduction on geothermal and solar available. Depending on what utility company you have and who you go with, there can be thousands of dollars there. Some states have property assessed clean energy that can pretty much give you a return on investment up to 20 years. Some states have that for single family. Some of them only have it for commercial. We see on-bill financing coming on for existing buildings and homes that help you pay for the cost, your clients pay for the cost of these upgrades through their utility bills. We see programs that are locally run, state-based run programs that have energy efficiency financing available to them that don't require appraisals and have low introductory interest rates. There's an entity called Green Energy Money that's financing zero energy homes right out of the gate all across the country. And then being launched in May, I'm really excited about this, is the Freddie Mac Green Choice Mortgage. And the whole idea here is that, again, the appraisers aren't going to understand all this, you know, for most aspects, no matter how much we try to show them, or educate them. We want to help them get there, but they're not going to understand it, or they're going to be nervous about liability. And so what Green Choice Mortgage does is sort of circumvent the appraisal and says, okay, we understand that you're going to need an extra 10 to 15% extra above the cost of construction code, maybe that high, hopefully not. So we're going to let your client borrow that because we know your utility bill is going to be zero or low. We know you're going to have a more durable and healthy home. And we know that that's going to help guarantee we're going to get paid back as the lender. And so lenders can utilize this Green Choice Mortgage for your clients who don't have the out-of-pocket money to pay for this, like most of us, if the construction costs come above code. So we went a little bit over time today, but I thank you for sticking around. I want to say a huge thanks to our top tier sponsors for allowing us to do what we do. Shrinergy for on the go or in your house, backup all electric solar battery solutions. Mitsubishi Electric for air source heat pump systems that work even down to -13, like it is potentially today in some places, to help you go all electric and zero. and then T-stud, structurally insulated framing systems that save money behind the walls. So I know we're over a little bit, but I see several questions here, and I'm going to try to get to some of those questions here. And then as far as the CEUs go, give me a second here, and I'm going to throw a survey right into the chat box, and then you'll be able to take that now. So I just put that survey in the chat box. Make sure to click that and take that while we're going through the Q&A session here. All right, so there was a very specific question here about using, I think, the Passive House Planning Package for radiant systems. Oh, I'm sorry. This was using hot water heaters for radiant systems. You know, that's a really good question. And you're saying that REAM says it won't work and SADAN doesn't encourage it. You know, interestingly enough, I just talked to a builder in Alaska who's moving here, and they're going to be using the SADAN, I think, CO2 heat pump water heater. According to them, they've been using this in Alaska all day long for their entire heating needs, and they're going to try to do it here, you know, much less, well, not right now, but less cold here. So they think it's going to work. They say it works. We see it working. So we know it works. You know, whether the manufacturers actually want you to do that, that's a great question, and I haven't really looked into it that much, nor do we see it that often, especially from an expense. So again, we want you to be able to do this in an affordable way, and radiant for the most part really isn't, from an affordability standpoint, it's really not the most affordable way to heat a house. It really can't cool a house. They're working on that. It's definitely the most comfortable system in the world, but you know, again, it's going to be the most expensive system, and so, you know, it's not necessarily something that we're targeting, but it could be a good idea. Yes. So do you have a source that confirms 40% more efficient induction cooktop over resistant electric coils? So yeah, there is a source, a study done, I want to say by the Department of Energy. I have a link to it. If you follow the link in the website to Going All Electric, you know, resources on our website or on some other websites, you'll find that in there, and I can share that with you if you want to have that too. So the question was, what about HRVs, ERVs? Yeah, you know, we kind of rolled through everything really fast. But again, from an affordability standpoint, we are starting to find that HRVs and ERVs, you know, if you run the calculations and the modeling, they aren't necessarily something you have to have. What's important is you have balanced ventilation. And so there are lots of strategies to do balanced ventilation. Some could be as simple as a furnace intake to a bath fan. Others could be, you know, other devices that just simply move in air in and out of the house. And then, yeah, on the flip side of that, there are what we call smart ventilation systems that run really low energy and then only ramp up when they detect pollution in the house and then go to exhaust it then. And some of those systems, like the one from Build Equinox, have an integrated heat pump. And theoretically, if you've got a tight enough home or tight enough multifamily unit, it could be the system that serves the heating, cooling, dehumidification, and ventilation of the entire unit, or maybe pair it. We see a lot of folks pairing it with a mini split to service the whole house as well. So, you know, ERVs and HRVs, I think, can be a financial burden to people who are really on a low budget trying to do this. And so they can be a distraction, but you really want to look at that, that balanced ventilation is key. And then in your energy model, you can say we're using balanced without heat recovery, and then it will tell you what your energy penalty is there. And then you kind of have to make a decision whether you want to go with a full-on HRV, ERV, or smart ventilation system. So the next one is geothermal system in a survey area example shown cost effective. So, you know, cost effective, again, is one of those terms where it's all relevant. So in their case, in that actual project that I've shown, you know, you are a point when you bore down vertically, it can be an extra I've seen prices range from an extra $1,000 to $20,000 to bore vertically down into the ground versus horizontal in a more rural or suburban setting. And so you're right, that does add a lot more cost. However, in their case, we modeled the house out just really quick. We modeled it against like a gas furnace versus like an air source ducted heat pump or mini splits. And at the time, and technology has changed so fast, but at the time, they didn't have anything available that could get them down to net zero, even for the size of their home, and even for the if you read the case study on the house on our website or take the tour, I mean they did a really robust wall assembly, and even then they still couldn't get the home down to zero with what was available at the time without using geothermal. And so so maybe the word cost effective for the average person, that's that's debatable. But their goal, again, from the outset was net zero, and that was the only way that they could get there. So hopefully that answers a couple of those questions. How much insulation should the slab have under it and on the sides? So that's a great question. So if you go to Passive House Institute US or the German program, they have sort of these guidelines on slab insulation depending on what climate zone you're in. And then of course also if you're running your energy models, like I shown you in that one slide, it's going to kind of tell you where your energy demand is going. So I always tell people to kind of use that as their guide. So again, you can see, the slab insulation on this particular project. Yeah, that's kind of like the third issue here. So is it worth addressing? How much does it cost to add insulation there? What do you need to do? So it's all kind of relevant to the entire, project in general. But just kind of off the cuff, we recommend anywhere from, and this is depending on your climate zone, anywhere from R5 to ideally R20 up here. And the thing about slab insulation is something you're never going to ever change later on in the future. So you might as well just do it right from the beginning. And that goes the same with insulation in the attic and the walls too. Very difficult to change that stuff, very expensive to change that stuff in the future. So why not just, boost it out from the beginning and make the house more resilient, especially if there should be a power outage or, a heat wave or in this case, a polar vortex. Oh yeah, so there was some question about the software. So if I didn't answer that correctly, that I just shown, that is RemRate, which you can go and download now and get free access to. And we're going to be doing a class on how to use RemRate as a non-energy rater to make informed net zero design. So we are going to be doing that course coming up. So stay tuned for that. Question about ERVs. So as far as PV shingles go, obviously Tesla's kind of got the claim to fame on that one. And from what I understand about their shingles is that they're cost competitive with slate, is my understanding. So, that's pretty expensive. But other than that, they, look beautiful, and they assume, from what I can tell, they work great and they've got good warranties. Now, Dow Powerhouse used to be sort of the #1 solar shingle back in the day, and then they stopped manufacturing them, but RGS Solar just picked them up, and they seem to be taking off really fast with an affordable product that's comparable in design and efficiency. And then I believe Saint-Gobain and Certainteed have had ones as well for quite a long time. There's another company, believe it or not, in southeast Michigan that's been around for a long time doing more metal roof looking like integrated solar. And then I just saw the country's largest roofing company is launching a full-on solar shingle program somehow. I didn't quite, I read the press release and I didn't quite understand exactly what they were doing, or I don't know if it gave us all the details, but yeah, they are starting to pick up. And then there is somebody who wanted to counter and say solar integrated shingles are a poor choice for longevity and performance. So yeah, great point. I mean, I think, some of the older models definitely didn't have much durability to them. But I do believe that is starting to change, and I think they're all, they're getting great warranties on them as well. So, typically that's a good sign. But yeah, proceed with caution. And then someone else chimed in, I currently use a traditional water heater, gas-fired water heater on my radiant floor slab, and been using it for 15 years. So there's some examples of water heaters being used for radiant. So there was a question about percentage of single-family homes, and forgive me if I think I'm saying this right, but that are using energy modeling early and often. And so part of that is code driven. So if the code requires you submit an energy model, well, then it's obviously legally required. And then in many other cases, the code might just require you submit a final model and inspection. And so that's the crux. We see a lot of people calling up the energy rater at the end of the project and saying, hey, come out and model my house and tell me how I did. And at that point, it's too late. And so, there's not much that can be done. And I think, the HERS rating is being used on 1/3 of all newly built homes, and then there's other models. So to what extent of those 1/3 of new homes that are using the HERS rating are actually doing initial energy modeling to inform design, I don't know. It's maybe a small percent. Because again, especially in this market, we got to keep moving fast. We don't really have time to slow down and think through some of this stuff. And so unfortunately, things are getting designed, which they probably could have been designed better, but everybody's in a hurry to get the house built and move on to the next project, especially with the housing shortages that we're facing here too. Oh, the cost of the energy modeling. Yeah, so cost, I try to stay away from that. Because it is hyper contingent and subjective to the market and who you're working with and how much they know. And so, I mean, if you wanted to just throw something out there, I mean, you might be looking at anywhere from, $300 to $5,000, depending on where you're at, who they are, what you're asking them to do, how many iterations you're asking them to give you, how many different packages you want them to review. It can really be all over the place. And so someone asked for a question on that pyramid there. Well, I don't see any other questions, and we are definitely at our time here. But thank you all for bearing with us. Like I said, I just put up a link for those of you watching this session on live. You can take that link and be able to get your CEUs that way. The slides have all been emailed out, so make sure to check your spam for that. For those of you listening to the recording, that's on demand, so none of you live right now, make sure to take your continuing education quiz and get an 80% passing rate, and then you will be able to obtain your CEUs that way. Thank you everyone for joining us. We want to continue this conversation on zero energy. So if you have any ideas or any leads on people doing something like this, we want to highlight that. We want to get the word out about what they're doing, and just keep talking about it. So thank you again. Take care.